Hello, I am Aiden Burnett.
And I'm Austin Coster, and we're doing our presentation on the Cummins ISL engine fuel system.
Our vehicle is the Gillig's low-floor transit bus, and as you can see the serial number on the screen here.
The engine that is in this bus is the Cummins ISL9 CM2250. It is equipped with a high-pressure common rail fuel system. The engine has EPA 2013 certification for emissions, and once again you can see the engine serial number on the screen. So for our engine here, we have a common rail fuel system, so it isn't too complicated. The first image here shows a schematic of the fuel flow through the engine itself. You can see that it starts here on the suction side and goes through the primary filter / water separator to the lift pump. The lift pump is mounted to the back of the ECM and has fuel that flows through the ECM cooler plate to regulate temperature. This lift pump is an electric lift pump that supplies fuel at around 20 or more psi to the gear pump. The gear pump is mounted directly to the back of the high pressure fuel pump, as you can see here. Fuel flows out of the gear pump at around 100 psi to the final / secondary fuel filter. From the final / secondary fuel filter, it is then fed into the high pressure fuel pump. Fuel is then pressurized to around 26,000 psi and fed into the fuel rail. From the fuel rail, the fuel is then fed to each injector through a high pressure line. The high pressure fuel pump, rail, and injectors all have a return back to the return block before going back to the tank.
The next two images show a better graphical representation of what we just explained. As you can see, the injectors here have a shared common passage for return. There's also a return block for all the rest of the return fuel. As you can see, the high pressure fuel pump also has a return here. And then this image here also shows the ECM cooling plate and each wire connected to each injector from the ECM.
The high pressure fuel pump in our fuel system is a two-stage pump that includes a low pressure gear pump and a high pressure cam plunger style pump. Both pumps are driven by a gear in the front cover from the camshaft gear, and the camshaft gear is driven off the crankshaft gear. This fuel pump needs to be timed so that the fuel pressure spikes that are generated during running don't interfere with the impulses generated by the injectors, or damage could occur to the system. The low pressure pump is coupled into the back of the high pressure pump as seen in the picture. The low pressure pump supplies the high pressure pump with adequate amounts of fuel that are demanded. To get the high pressure fuel to such a high pressure, the fuel pump has an internal cam that drives the plungers. These plungers are responsible for the pressure that is generated.
The amount of fuel delivered into the high pressure fuel pump is directly controlled by the fuel pump actuator, which meters the amount of fuel. This actuator is controlled by the engine ECU. The engine ECU is constantly getting information from a variety of position, temperature, and pressure sensors to determine how much fuel needs to be delivered to the high pressure pump. Under high load, the actuator will open more and allow more fuel to flow. During low load or idle, only the required amount of fuel will be delivered to the high pressure pump, which reduces parasitic losses in the system. All the high pressure fuel that is produced by the pump is sent into the fuel rail. The fuel rail acts like an accumulator, absorbing pressure spikes while also supplying each injector with fuel.
The injectors in the ISL9 are a fully electronically controlled style injector. These injectors are supplied by individual fuel lines that connect to the fuel rail. From the line, there is an internal passage through the cylinder head that the fuel flows into the injector as shown here.
Next, you can see there is a supply inlet passage inside the injector that feeds a cavity inside the top of the injector and down to the injector tip as shown here. So here's the cavity up top, and then it also feeds down into the injector. The cavity inside the top of the injector houses a small valve ball that is exposed to high pressure fuel, but is held closed by a spring, as you can see here. An electronic coil is energized and allows the valve ball to lift off its seat, allowing fuel to flow past it. The fuel that is let past the check ball then acts on a larger surface area, lifting the injector tip, which allows high-pressure fuel to be injected into the cylinder. Once the coil is de-energized, the ball will reseat and end the injection.
Here we can see how any small amounts of debris, dirt, or abrasives can cause an injector to be considered out of service. The injectors need to remain very clean to operate properly. Here we can see the injector installed in the head and the injector wire harness that runs to the injectors. Another important thing to know about the operation of these injectors is the fact that they need to be calibrated with Cummins Insight anytime an injector is repaired or replaced. Each injector has a trim code and will need to be updated when installing an injector so that the ECM knows what injector is in the engine. Also, be sure to disconnect batteries when first removing and reinstalling injectors to avoid internal damage to the injector.
The safety procedure to open up the fuel system has a few steps. It is first important to know the dangers associated with the high pressure that is within the system and how it can severely injure or kill you if you don't respect the safety procedures. Do not remove any line on the high side of the system when the engine is running. First, allow the engine to set for around 10 minutes after turning off the engine. This allows some of the fuel pressure to bleed off from the rail. Before removing the lines, connect the engine using Cummins Insight and a suitable COM adapter. Using the parameters, you can look up rail pressure. Now carefully remove the line from the pump to the rail, as shown here. It has a slotted relief cut in the fitting to release the pressure towards the engine block. Next, recheck the pressure in Cummins Insight to verify that the rail pressure has reached 0 psi. Now you can safely service the rest of the high side system. The high pressure fuel lines and rail can be reused for our application after each component has been thoroughly inspected for debris or damage.
In order to properly prime the fuel system during a filter change, you must cycle the key 3 times for 30 seconds each time. This allows the lift pump to prime the system before starting the engine. You may need to cycle the key more than 3 times depending on the fuel system. If it's hard starting, there may still be air trapped in the system. In this case, you may need to run the engine for some time to get the air out of the system. If there's a no start condition, you may need to follow troubleshooting procedures found in the testing for air in the system.
There are many different tests that can be performed on this fuel system. Some of the tests can take place within Cummins Insight program using diagnostic software and a computer, such as a cylinder cutout test, idle speed balance, and more. You can also monitor parameters to aid in troubleshooting problems. There are some common areas on the engine that are good to know about when needing to perform a test. The fuel return manifold, as shown here, is a point where many tests can take place. Measuring fuel from the return and comparing it to specified quantities in a certain time frame can further help us troubleshoot any problems that we may be having.
As you can see in these pictures, we have lines going to the filter header, which can be removed to find flow coming from our low pressure gear pump. Measuring fuel amounts and pressures can help determine the health of the low pressure pump as long as we know our charge pump is good. We can also hook up pressure gauges in line with the system to monitor fuel pressure through the suction and low side of the system. As you can see in the image here, we are monitoring the low side return pressures and flow to aid in troubleshooting problems with this system. For our diagnostic software, we are using the Cummins Insight program with a Nexic COM adapter. We have a short video on the diagnostic software for you here showing off how to perform a cylinder cutout test and how to look at parameters.
To access Cummins Insight, we have to click on the Cummins Insight app. make sure you have it downloaded on your laptop. For my purposes, we're going to go into simulator mode, but on the actual engine we would connect to it through a COM adapter. Now that we've loaded into Insight, we're going to click Connect to ECM. Now we're going to hit Connect down here, and we should be connected to the ECM. Oh, here's the work order. You just hit OK and it'll create a work order for you. You can go in fault codes, diagnostic monitor logger, ECM diagnostics. There's a bunch of different things you can select in Cummins Insight. We're going to click on ECM diagnostic tests right here. And then we're going to go to cylinder cutout test. Once we're in cylinder cutout test, we need to ensure the engine is running, make sure the air conditioning is off, and the engine fan is in the on position. Coolant temperature also needs to be above 170 degrees. So we're going to hit start here on the cylinder cutout test. Once we hit start, these boxes will light up and we can click on each different one and it will cut out the engine, and you can listen for the noise of the engine to see if it is turning on or off. Each cylinder, you can kind of hear it, the pitch changes. You can also go into the data monitor logger and select certain parameters depending on what we're trying to monitor. Here we have % fuel and % throttle selected. There are many other monitors for fuel system, like water and fuel right here, but each of them helps you diagnose any problems that you might be having with the fuel system.
Alright, so we're going to do a cylinder cutout test on this engine here in the bus. First we got to go to Cummins Insight, and we're going to go to ECM diagnostic test, and then we're going to do cylinder cutout test. The engine needs to be running, and we need to scroll down and hit start here. Once we hit start on the test, we can cut out different cylinders. We're going to do cylinder 1. You should be able to hear the engine change. Alright, that's how you do a cylinder cutout test. You can hear the pitch of the engine change depending on what cylinder you're cutting out.